Hi everyone, today we're going to deal with parts of a chemical reaction and writing some word equations. The first thing we have to talk about are the indications of a chemical reaction, how you know something actually reacted. And there are four ways we're going to sort of deal with this. The first one is if you have the formation of a precipitate. A precipitate is a solid that comes from two aqueous solutions when they're mixed. We'll do this in lab, you'll see it. It's kind of a cool thing. Second is formation of a gas, and the way you can tell a gas is formed is by seeing bubbles. The third one is formation of water. You can't really tell that, but just keep that in mind. And then there's some characteristic changes that mean a reaction's happened, such as a change in odor, or a change in color, or a change in heat. All of these things indicate that an actual reaction happened. Now we're going to deal with the different parts of the chemical reaction. We generally write with the reactants over here. These reactants, okay, are what are going to mix. Then there's an arrow, and the computer doesn't really draw arrows very well on this PowerPoint, so this would be an arrow, and it goes to the products, okay? The products are what is formed. Now if you notice down here where it says states of matter, underneath and behind each one of these chemicals is an AQ, AQ, S, and this one has an AQ but it didn't fit, and those mean what state it is. So an S means you have a solid, an L is a liquid, G is a gas, and AQ is something a little funky. It's called aqueous. That means that normally we get our silver nitrate right here in a solid form. And what we do is we put that into some water and make a solution. So all we have is silver nitrate in solution. Okay? And so that's the basic idea of a chemical reaction. Now, when you write a chemical formula, you must write each chemical correctly first. Otherwise, you get into a lot of trouble, which is last unit. You need to know that the word and or is mixed with or reacts with is like the plus sign, okay? And the word yields, produces, or forms is the arrow, okay? That's what those two mean. And this right here, remember, Hunclebriff. Oh yeah, your Uncle Hunclebriff. Okay, that'll come back into play soon. Now this big chart you have right here is a chart that explains what all the different symbols are that can be in a reaction. Now I'm just going to put that up there for you to have. We'll use most of them, but it's just good to see that there are lots of different symbols that you can. So let's practice. Aluminum metal is reacted with aqueous hydrochloric acid to form solid aluminum chloride and hydrogen gas. So we are going to actually write this out. Aluminum metal. So you write Al, and if you look on the periodic table, metals are mostly solids, and you know aluminum foil at room temperature is a solid, so you're going to put an S behind it. Is reacted with aqueous hydrochloric acid. We haven't learned what hydrochloric acid is yet, but we will. But you're going to write it down, the symbol HCl, okay? And it's aqueous, so it'll have an AQ behind it. To form is the arrow, so we're going to draw an arrow. Solid aluminum chloride, but this is where old stuff comes into play. Aluminum has a charge of +3. Chlorine has a charge of -1. They don't cancel out, so you have to crisscross, and that becomes AlCl3. And it's a solid, so you're going to put S. Plus, and I'm going to draw an arrow down here because I ran out of space, hydrogen gas. Hydrogen gas is H, but there's still an issue here, ladies and gentlemen. Hydrogen is a Hunclebriff, so it's H2 gas. Alright, so that's drawing out a word problem. Let's try it again. Aqueous copper 2 nitrate and aqueous sodium hydroxide form solid copper 2 hydroxide and aqueous sodium nitrate. So I'm going to start by drawing these out. I'm going to do them up at the top. Copper 2 is copper +2. Nitrate is NO3. And the whole thing has a charge of -1. The charges don't cancel, so we crisscross. It becomes Cu parentheses, NO3, 2. And it's aqueous, so we write AQ. Plus aqueous sodium hydroxide. Let's take that for a minute. Sodium was Na plus 1. Hydroxide is OH minus 1. Since their charges cancel, we can just write NaOH. Okay, and it's aqueous, so we're going to go AQ. Form is the arrow. Okay, they produce or form or make. And this is solid copper 2 hydroxide. So now we're going to still take this copper plus 2 and this OH minus 1. Their charges don't change. So that becomes Cu parentheses OH close parentheses 2. And it's solid, so I put parentheses S. And means plus. Now it's aqueous sodium nitrate. Remember, sodium is Na plus 1. Nitrate is NO3 minus 1. That becomes Na NO3. Okay, and this is AQ. Please ignore my pen, and hopefully you can get all this in a straight line. Now we're going to do something called balancing equations. Okay? Balancing means that everything on the reactant side has to equal everything on the product side. There has to be the same amount. Things just don't disappear. Okay? So one of the things that we do is we make something I like to call a RIP chart. R-I-P. Well, the I isn't really there. And I list all the reactants over here and products, and we make charts of their numbers. And we add coefficients to balance. Alright, so let's try one. So what we have here is a chemical formula that, of course, doesn't turn out beautifully with the computer, so I'm going to try it this way. So here we go. CH4 plus, and these blank lines we're going to draw on. That's where the coefficients go. Plus O2 yields H2O plus CO2. Now what we do is we take each different chemical or each different element, carbon, hydrogen, carbon's right here, hydrogen, and oxygen, and we see how many we have. On the reactant side, I have 1 carbon. On this side, I have 1 carbon. So that's nice and balanced. Now on the reactant side, how many hydrogens do I have? I have this 4 right here, so I'm going to put 4. But on the product side, I only have 2, so I'm going to put 2. Oxygen on the reactant side, there are 2. But over here on the product side, I have oxygen here and oxygen here. There's 1 plus 2, so that's 3. So what we're going to do is we add numbers that go before the chemical that get multiplied by each element, okay, to balance this out. So I have the same number of carbons. Hydrogen is a 4 and 2. That seems pretty easy, but this 2 and 3, they have to be whole numbers. So we've got to figure out how to figure out oxygen. And I can do this, and I can see this because I've balanced a lot of equations in my time. If I put a 2 there, now all of a sudden I have 2 oxygens plus, I have 2 oxygens right here, plus these 2, and this becomes 4. Can I easily fix the other oxygen? What can I do to make this 4? If I put a 2 here, 2 times 2, that's 4. Now, in the process, did anything change? If we put this 2 over here in front of this oxygen, it also changed this hydrogen. 2 times 2 is 4. And we are completely balanced. Everything is the same on each side. I'm going to put 1s here. If there's nothing written in front of them, it means it's a 1. 1 times this 1 carbon, 1 times this 2 oxygen. So that's balancing by inspection. And this RIP chart is pretty simple to do. Now sometimes we have to use polyatomic ions, and the easiest way to do it is to leave your polyatomic ions together if they appear on both sides. However, sometimes it seems like OH doesn't appear on both sides, but this one is sometimes hidden in H2O. Another way to write H2O is HOH to see the polyatomic on each side. Alright, so now this reaction is a little funky because of the writing, how it actually turned out. This is supposed to be, and hopefully you have this on your guided notes, H3PO4 plus Ca parentheses OH2 yields Ca3PO4 2 plus HOH. So if you notice here, hydrogen, on this side I have 3 hydrogens by itself, so I'm going to put 3. And on this side, I'm going to split this HOH in half, and I actually only have 1 H. What about that OH, you say? Well, that OH we're going to deal with by looking at the OH down here, okay? So what that means is that how many OHs do I have over here on this side? I just have 1 OH. And on this side, I have, you see that two OH groups. So now with the PO4, if I look at the reactant side of PO4, that's right there. There's 1 PO4. But over here, that 2 comes behind it, there's 2 PO4 groups. And calcium's easy. This side, reactants, there's 1. And on this side, it's Ca3, so there are 3 of them. So now we have to balance everything out. So the first thing I see here is that my hydrogens don't balance, but my hydrogens are also going to be related to my hydroxide. So I'm going to leave that for the end. Let's try the PO4s first. If I have 2 right here, on this side I'm going to put a 2, so now I have 2 times that. So now I have 2 PO4s. Now they balance, but now I have 2 times 3, 6 hydrogens over here. We'll have to deal with that in a minute. Now what about calcium? Calcium on this side is 1, but over here is 3. So what I'll do is add a 3 as the coefficient. And when I do that, the calcium's balance, but now this 3 goes with this OH, and we already had 2. So 3 times 2 is 6. So now I have 6 OHs. Well, how do I balance 6 OHs over here on this other side? If I put a 6, I now have 6 OHs, and I have 6 individual H's, and we are balanced. This is a balanced equation. This is kind of a tricky one, but I thought it would be fun to show you kind of a hard one. Let's practice some more. Alright, we have this other equation here. We're going to balance this. I'm going to rewrite the equation for you so that you can see what all these actually should be. HCl plus CaOH2 yields CaCl2. And this time, do you see how there's an OH right here? We're going to make it so this side has an OH. So this is HOH. Alright? Now on this HOH and this whole thing, we need to make a RIP chart. So I'm going to do it up high. I'm going to put reactants. I'm going to put products. I'm going to separate them into H, Cl, Ca, and now we're to OH. Okay? So on the reactant side, I have 1 H, I have 1 Cl, I have 1 calcium, and I have right here 2 OHs. On the other side, remember we separate our HOH right here to 2 pieces. So I have 1 H, I have 2 Cls, I have 1 calcium, and then over here I have 1 OH. So somehow I got to get this bad boy balanced, and I'm going to start with the calcium or the chlorine because it seems like a first thing. This side has 2. How do we get 2 on this side? We're going to put a 2 in front. We put that 2 in front. Awesome. Now we have 2 chlorine. We're set on chlorines. But now this becomes 2 hydrogens too. So now we have 2 hydrogens to 1. How do we get 2 hydrogens on this side? If I put a 2 here, the 2 distributes over the whole thing. So now I have 2 hydrogens and I have 2 OHs. And guess what? This is the same, this is the same. We are balanced. So if I were to draw in these lines, I'd put 2, 1, 1, 2. That's a balanced equation. All right, let's try this one. This is a simple one. H2 plus O2 makes H2O. All right, notice they didn't give you states of matter, so we're not going to worry. However, you pretty much can figure these out. If you look on the periodic table, hydrogen's a gas, because it's red, oxygen's a gas, and water is a liquid. You know that at room temperature, that's what water is. So now in order to balance this, you need to make a RIP chart. In this case, okay, we have hydrogen and we have oxygen. We don't need to change the H2O to HOH because there isn't an HOH on the other side. So we don't need this right now. That's just extra work. So over here now we have 2 hydrogens. Right here we have 2 oxygens. And over on the product side, 2 hydrogens and 1 oxygen. So the only thing we have to balance over here is this oxygen right here. So how do we get that to have 2? We're going to put a 2 in front of the whole thing. Whole numbers only. That changes that to 2, but it also changes the hydrogen. 2 times 2 is 4. So on the reactant side, how do we make this hydrogen 4? All we have to do is put a 2. This becomes 4, and everything is balanced out. Set. So if we're going to put these in these little lines, you'd have a 2, a 1, and a 2. Balanced. Next. All right, and I'm going to rewrite it here. This is just Fe plus O2 yields Fe2O3. Okay? I'm going to make the RIP chart down here so you can see it a little better. And I have room. So it's RIP. I have Fe. And I have O. Those are only things I have. So on the reactant side, this is this right here. I have 1 Fe. And the oxygen, I have 2. Over on the product side, for Fe, I have Fe times 2, so that's 2. And I have oxygen over here. There's 3 of them. So I'm going to add coefficients, but it's going to change everything. There's lots of changing that's going to happen. And whenever I see a 2 and a 3, I think 2 times 3 equals 6. And so I'm going to put a 3 here, so that equals 6. And I'm going to put a 2 here, so 2 times 3, that equals 6. So I have 6's. That's cool. But this also changed up here, my iron. 2 times 2 is 4. So now I have to go onto this other side. What can I put here to make this balanced? So I'm going to put a 4. And it's balanced because now there are 4. So if I were to draw these in the lines, 4, 3, 2. So here we go. We're doing another one. This one's really similar to the one at the beginning. So if we have Al plus HCl yields AlCl3 plus H2, what we're going to do is make a RIP chart. Our reactants, so that's these guys. P products, these guys on this side of the arrow. And that looks like I have Al, H, and Cl. That's it. On this side, it's really simple. I have 1 Al, 1 H, and 1 Cl. Now on the other side, though, aluminum right here, I have 1. Chlorine, there's 3. And hydrogen, there's 2. So, ladies and gentlemen, one of the first things I'm going to do here is I'm going to check out the chlorine. I can fix this chlorine. Here's 3 on this side if I put a 3 right there. And now that's balanced. But now I have 3 times H, so now I have 3 hydrogens. And I have this silly 3-2 thing. 3 times 2 is what? 6. Okay, so when all else fails, let's make it 6. So we're going to erase this, okay? And it's not always easy to erase. Okay, so I'm going to go through and I'm going to erase this 3. It's Pretty straightforward. And I'm going to make it a 6. So now that I have that, holy moly, I have, this is a 6. But now my chlorine, 6 times chlorine, so now my chlorine is 6. Cool. Now my chlorine isn't set, but that's cool. I have that 6 over here. I think I can fix it eventually. So now hydrogen on the other side, how do we make this hydrogen 6? We put a 3. So now our hydrogens are matched up. Now let's go back to our chlorine. There's 6 on this side, on the reactants. How do we get 6 on the product side? I'm going to put a 2 there. 2 times 3 is 6. So now that's even, but now the aluminums become 2. So now that I have 2 aluminums, how do I get 2 aluminums on this side? I'm going to put a 2 in front of it. And that is all balanced out. Make sure you have the same amount on each side. One last one, and this is one that we're going to use the polyatomic ions. And this gets faster. At some point, you might be able to do it without the RIP chart, but for now, we're going to use it. So I'm going to rewrite this, CuNO3, 2. That is a reactant. I'm going to skip the aqueous because I don't have a lot of room here on my paper. Plus NaOH yields CuOH2 plus NaNO3. So now that I have that, I'm going to make a RIP chart. So I'll put it over here. Our reactants, P products. So everything on the reactant side is on this side of the arrow, and this is on the other side. So I'm going to just make a list of my stuff. I have copper. I have nitrate. NO3 stays together. I have Na, and I have OH. We're going to keep that together too. So right here for copper, I have 1. Right here for nitrate, because of that, I have 2. Right here for Na, I have 1. And OH right here, I have 1. Now we go to the other side. Copper, I just have 1. That 2 goes for the OH. So right here, that 2, that's 2 for the OH. And over here, there's 1 Na. And over here, there's 1 NO3 group. That group, just one of them. So I'm seeing that I have an OH, and an NO3 issue. Those are the things that aren't balanced. So if I have 2 NO3s over here, I'm going to go to the product side and somehow get 2 on this side. I can't add anything behind, only in front. So I'm going to put a 2. And when I put that 2 there, that's balanced. But oh man, that changes my sodium. So it's 2 times Na. So now I have 2 of those. Which might seem like we're just making a bigger problem, but it's going to work out. Alright, so now I'm going to look at my, this is done, so I'm going to look at my OH. I have 2 OHs over here, but on the reactant side I just have this 1. What can I do? Well, I'm going to put a 2 here, and what that does is it means I have 2 OHs now. And now it also means I have 2 Na. Are we balanced? 1 to 1, 2 to 2, 2 to 2, 2 to 2. We are balanced. And that's the end for now. I think that this should give you a pretty good start on trying to balance some equations. Thanks!